All right, starting lesson 1.5, analyzing graphs of functions. All right, two very important terms to understand the meaning of is domain, all right, which is all the values you can input into a function. These could also be known as your x values. All right, then there's the range. The range is all the values that can be output by a function. You could think of that as the y values. All right, so you plug in an x value, and what do you get back? A y value. Your x is your input, your y is your output. All right, so for example 1, use the graph of the function to find the domain and the range. All right, once again, what is domain? It's the x values. So looking at this graph, what x values are covered by it? Well, let's see. Here's my x values, starting at 2. I'm going to the left, going to the left, going to the left, and it just keeps going on forever to the left. All right, we're just going to keep covering more and more x values. All right, and then going to the right here, going to the right, we're covering more x values, and it's just going to keep going to the right. So it's going to cover all the x values to the right, all the x values to the left. All right, so that means we're covering all real numbers for the domain. All right, but we're going to express this using this type of notation here. All right, this is known as interval notation. So we're starting from over here, negative infinity. All right, and we keep going to the right, and it just keeps on going to positive infinity. All right, now whenever you use infinity, make sure you use only parentheses. Now for range, what's happening here? Well, let's look at the y values that are covered by the graph. Now, at this point, the y value is 0, right? Y value is 0. And then there aren't any points below 0. Okay, so that means I'm starting at 0, and then the graph starts to rise on both sides. So you're starting at 0, and then it starts to go upwards, going both directions for x. Okay, so for the range, we're starting at 0, and we're going up, 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 and it just keeps going up, 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 both directions. So we're going up to infinity. All right, now for infinity, we use a parentheses. And for this value here, for 0, it's including that value, so we have to use a bracket. All right, now that's the interval notation for the range. All right, next example for domain. All right, here I'm starting at the left, and I'm going to the right. That's negative infinity. All right, and then I stop at 1. There's a gap there. And then I pick up at 1 again, but there's a gap there. And I continue going to the right. Notice there's a gap here for both of these. So that means the domain includes all real numbers, all right, except 1. All right, now let's describe this using interval notation. I'm starting from negative infinity, and I stop at 1. But does it include 1? No, it does not include 1. So parentheses. I'm going to use this union symbol here. It's like an and. You're including it. You're attaching it to this other interval. And I pick up at 1 again, but I don't include it. And then I go to positive infinity and use a parentheses for infinity once again. And that's our domain. Now for range, what's going on with range? Well, let's look at all the y values here. What are all the y values here? All the y values here are negative 1. And what are all the y values here? They are just 1. All right, and that's it. You just have 2 solutions for the range, and that's it. So moving on to the next example. All right, we're not putting parentheses around these. All right, it's not a point. Be careful with that. That's one part to the range, and that's the other part to the range. There's just 2 values that represent the range. Going on to example 2. All right, example 2. These problems look complicated, but they're actually very, very simple problems to do. Let's see what's going on here. So here I have my function. I'm evaluating it at negative 1. That means negative 1 is my input, or my x value, and I need to figure out what the output is. So let's find negative 1 on this graph. It's going to be right here. All right, so that's 2, so that's 3, and that would be 4, right? All right, so at negative 1, my y value is 4. And that's all there is to it. You just want to know what your y value is, your output. Now, when x is 2, my y value is 3. When x is 0, my y value is 2. When x is 1, my y value is 0. All right, see how simple that was? That's all there is to these. For part B, let's look at A. All right, my input is 2. Let's find 2. And my output, my y, is 0. And for part B here, x is 1. What is the y value? X is 1. Here's my y value, 1. And for 3, here's 3. And I'm going to go up. It's not here. It's a little more. Yeah, right there. Okay. So then my output, or my y value, is 2. And for the last one, negative 1. What is my y value? Right here. It's 3. All right. Really simple stuff once you understand it all. All right, going on to the next example. Find the zeros of the function algebraically. All right, find the zeros. So what does that mean? Set the function equal to 0. So half x cubed minus x. All right, what can you do here? I'm just going to flip it around, and I could factor out at x. So half x squared minus 1 equals 0. And then I have x, let's see, set both of these factors equal to 0 to solve for x. All right, and I'm going to add 1 here. I'll multiply by 2. Take the square root of both sides. Don't forget the positive and the negative. So one of my solutions is x equals 0. And I have two other solutions, positive and negative, square root of 2. All right, that's all there is to that. Part B. All right, what am I going to do here? All right, this is it's going to be big X with grouping, or whatever method you use. I got to find two numbers that add up to 22, multiply to give me negative 48. That would be 24 and negative 2. All right, so I'm going to take the middle term, break it up using these two. So plus 24x minus 2x. Then I have the leftover constant. All right, now I have a 4-term polynomial. And I'm going to group the first two terms and the last two terms. Out of the first group, I could factor out a 3x, leaving me with x plus 8. Then I have a negative 2 I could pull out of the second group. X plus 8 left over, all equals 0. And then now, look at these two terms. What do they share in common? An x plus 8. So let's factor that out from both terms. And what's left over? 3x and the minus 2 equals 0. All right, now I have to solve. So I'm going to set each of these factors equal to 0. All right. All right, so x equals negative 8. Then here I'm going to add 2. 3x equals 2. Divide by 3. X is equal to 2/3. There's one solution. There's my second solution. All right, going on to example 4. All right, a piecewise function is a function that consists of parts of one or more functions based on certain restrictions. All right, determine the intervals over which the function is increasing. I'm looking at a piecewise function right here. All right, what is this crazy business? I have the graph of this below. All right, so 2x plus 1, that's a line. That's the line 2x plus 1 here. All right, but there's a restriction here applied to that. This is essentially the domain that they give you. So it's less than or equal to negative 1. So for the x values. So this is negative 1 for x values, and less than or equal to would be all these points here. So that's why all of this was cut off. All right? And then, oops. And then, let's see, we got x squared minus 2. Well, that's a quadratic, and we're going to get a parabola. So here we have this parabola, but it has a restriction applied to it. X is greater than -1. So that restricts the domain to all values of x greater than -1. So here's -1 for x, and here's all the points greater than -1. So that's why this piece was cut off from the graph. All right, so that's why it's called a piecewise function, because you're taking pieces of the function by restricting the domains. All right, now we have to figure out where the graph increases, where it decreases, where it's constant. Okay, increasing. Well, going from left to right here, increasing. And then what happens after that? Then it starts to decrease. And what happens from there? Then it begins to increase again. Right, it begins to rise again. So we're looking at the x values now. Whenever you're thinking about increasing, decreasing the constant, you're looking at the x values. So here, all my x values, it goes from -infinity, and then stops where? It stops at -1. And where else does it increase? It starts at 0, and then it goes to infinity. All right, now when you talk about increasing and decreasing, you never use brackets, because at a particular point, you can't describe a point as being increasing or decreasing. Only from going from one point to another is there an increase or a decrease. All right, how about decreasing? Okay, well, going back here, at this point, it begins to decrease, and then it stops. So what are my x values there? Well, it's from -1 to 0. And in this graph, is there any area in which it's constant? Constant is when it flatlines. All right, and in this case, we don't have that scenario, so there's no particular area that's constant. All right, we're done. Going on to the next example. Increase. Where's the graph increasing? All right, here it's increasing. All right, it's rising. All right, but I described the increase using the x values. So I'm starting over here from -infinity. And it stops where? It stops at 0 for x. Once again, we're talking about the x values. Then what happens here? All right, just flat lines. It's constant the whole time through. So what are the x values here? It's from 0 to 2. It's constant. All right, and then you have a decrease taking place here. It's going down. All right, well, now what are the x values for these points? Where it starts at 2, and then it goes forever to infinity. All right, that's all there is to these problems. If you need any help, let me know. Begin the assignment at the bottom of the webpage.